Okay, so now let's actually look at what's going on at the neuromuscular junction. So the whole purpose of this is to convey the message over to the muscle cell to contract. So it does this again through an action potential, which is what we just did. So the action potential travels down the neuron. So the neuron axon. So the action potential travels down the axon toward the terminals. And as it travels down here, and that just means it's being propagated down this axon. So the action potential is jumping down here, all the way down the plasma membrane of the neuron. Okay, so as it's traveling down here, that action potential is changing the voltage on the membrane all the way down. Okay, once it gets to here, this point right here, we see a channel. And same over here. It's coming down here and it sees this channel. It bumps into it. This is that voltage gated calcium channel. Okay, and that's the same thing. They're on both sides. So the voltage that comes through there opens these gates. When they open, calcium is going to enter. There is more calcium on the outside of the cell in the extracellular fluid than inside. So by diffusion, calcium goes right into the axon terminal there. Well, calcium does something that's very important. Calcium stimulates or causes, whatever you want to say, causes vesicles to want to go through exocytosis. Okay, so there's already vesicles here. We see them. Here's a vesicle. Here's a vesicle. And what's inside these vesicles? If you said acetylcholine, you are right. So these vesicles go down towards the, end plate, or, towards the bottom of the axon terminal, and they bind there and they exocytose. They open up and they barf out the acetylcholine into the cleft. So remember, this area here is the cleft, because again, the neuron does not touch the muscle cell. And then this area from here to here is the motor end plate. And that's, of course, just where the neuron is connecting with down to the muscle cell there. So now we have acetylcholine in the cleft. Well, what happens to it? Well, if you remember, and you can see them here, these guys, these are the chemically gated channels. So chemically gated channels. So these are channels on that motor end plate. They're not open, they're gated, okay? But the only way to open them is for some chemical, some neurotransmitter to bind to them. So here is where they bind. So that is the acetylcholine binding to these channels. And when they bind, the channels open. Okay, so they open. Well, okay, great. So what happens when they open? Well, obviously something's going to move. I mean, why would they open if nothing's going to happen? So we get movement here, and we get the diffusion of sodium, place to do this. So sodium will diffuse inside the cell, and potassium will diffuse outside of the cell. Okay, because we know that there's more potassium inside the cell than out, and there's more sodium outside than in. All right, but we also know that potassium is moving out the amount of it is at a higher rate because there are way more leaky channels for potassium than there are for sodium. So that means the gradient for sodium is going to be higher because there's more out there trying to get in, and there's not many ways to get in. So when this opens up, the sodium diffuses more. So we get more sodium in than potassium out. And that more sodium in, so more sodium into the cell, changes the potential, changes the voltage, and it changes it just along the motor end plate. Along the motor end plate. And it's making it more positive. Okay, sodium's a positive ion. It's coming in. The inside is resting and it's at negative, but now more sodium's coming in, more positives, so it's making that motor end plate more negative. So it's making it charged. Okay, well, that charge will initiate the action potential along the rest of the membrane. Because guess what's over here? Guess what's here and here on either side of the neuromuscular junction? We have voltage gated channels for sodium and potassium. Now we have separate ones for sodium and separate ones for potassium. So the first ones that open up are going to be for sodium. Sodium. And then those are going to cause the opening of the next one, which would be for potassium. And potassium's going to go out. So that action potential, that change, is going to be propagated down the sarcolemma. All right, so let's get ready for the rest of the story here. So now we have our action potential. We've gotten it from the neuron. Neuron is done now. And now we've moved it over to the muscle cell, which is now propagating through the whole muscle cell. Now, just as a side here, this acetylcholine that's in the cleft, where does it go? What does it do? What happens to it? We can't continue to have, muscle contractions over and over again that we have no control over, okay, that aren't neurologically stimulated. So the acetylcholine has to be taken away from the cleft. So there is a substance, an enzyme called acetylcholine esterase. Anything that ends in ASE, ACE is an enzyme. And this enzyme here breaks down the acetylcholine that's in the cleft and gets rid of it. Okay? So that keeps us from having these aberrant, crazy contractions with no neurological stimulus. All right? So now the muscle cell is propagating its action potential and acetylcholine's getting kicked out. All right? So now what happens? Stay tuned.